Welcome. Today we're going to learn a new topic called simple linear regression. Now, why is this topic important? Well, I'm going to explain in a few seconds, but let's take 2 steps backwards. If you remember, in a prior video, the previous video, we talked about correlation, and we said it's a relationship between 2 variables. We said it does 2 important things. It tells you the strength as well as the direction of 2 variables. So you could have a strong and positive relationship between variables, or you can have a strong and negative relationship. Those are just examples, right? Well, one thing missing from correlation is that it's not the same thing as causation. What does that mean? That means that the fact that 2 things occur at the same time doesn't mean that one of them affects the other one. That is what is missing with correlation. And that is something that we're going to fix with a simple linear regression. In simple linear regression, we tend to have a scenario where we can tell by what percent one variable affects other variable. Now, why is that a big deal? Well, it's a big deal because a business, a company, an individual can make a better decision if they know by how much one variable affects another variable. Right? Think about it. If you want to increase your GPA, you already know that getting a tutor, spending more time with somebody helping you, helps you get a better grade. You know that. Now, supposing you find out that 60% of your good grades in your that ask your GPA is tied to getting help from a tutor. Or think of a business. Imagine a company that is struggling to increase sales, finds out that 50% of their sales is tied to having good ads. So now they can channel their finances towards marketing, because when they spend money on marketing, it's going to do what? Increase sales. So in this case, it is causation. More money spent on ads lead to what? More sales, more revenue, and possibly more profit and company's growth over time. Same thing. More time spent with the tutor, because that helps your GPA, means better grades, means you go to a better school, means that it's a chance that you can have higher earnings long term. So in this case, it's not just 2 variables, GPA and tutor, or sales and ad just going the same direction. We can tell by how much of what percent one affects the other. That is what makes this topic so much more important and valuable to an individual, to a business, to a corporation. So we're going to be able to do a couple of things with a simple linear regression. We're going to be able to tell how strong the relationship is between the 2 variables, but also how much one of the variables affects the other. Now, in a simple linear regression, you do have only 2 variables. So it's similar to correlation. But in this scenario, you have what we call an X variable and then a Y variable. The X variable is also known as the independent variable. The Y variable is known as the dependent variable. Think of the Y variable as something you want to understand. you want to explain, right? And then think of your X variable as that factor that helps you understand or explain Y. So in this scenario, X affects Y. So X is the variable that helps you explain, that helps you understand, that helps you in predicting Y, right? So think of the same example we used. Remember we talked about spending money for ads and then sales, right? Because the more money you spend in ads leads to higher sales, your ads would be X, which is the factors or the variable that helps you explain what Y, which is your sales. So those are the two key variables we're going to look at. And then my next video talks about a multiple regression. And that's because the simple linear regression, why it's very effective, is also has a key shortcoming. It holds the concept that only one variable affects another, but you know in reality, several factors affect variables. So even if you go to sales, while ads increase the value, other factors also play a role, right? And so other factors may be location, it could be type of goods being sold, it could be level of knowledge of your workers. And so you can see a scenario where other factors will play a role. And that is where a multiple regression plays a role. But for this example, or for this video, we're going to learn about simple linear regression, where one variable affects the other. Now, remember, it says simple linear regression, which means that it's a linear function, right? And so with a linear function, it means they're dealing with a straight line. And if you remember, right, for your basic equation of the line, it used to be y is equals to mx plus b, right? Where your m is your slope and your b is your y-intercept, right? The same thing occurs in this. The same thing, we're going to look at the relationship between x and y as described in form of a linear function. And so same thing applies. Here we'll have our y, which is our dependent variable. And in this scenario, we're also going to have our y-intercept, right? Which is written as beta naught, right? And that would be the regression intercept. We also have our slope, right? And it's just it's going to be the estimate of the regression slope, and then our independent variable. So our beta naught here, or beta sub O here, is the estimated mean value of y when the value of x is 0. And then this will stand as the estimated change in the value of y as a result of an increase in x. So a unit increase in x, right? So this is your slope, right? In this format. Now, some books might still leave it in this format. Some books might still leave it in this format. It doesn't change, right? It doesn't change your final results, which is the prediction, right? Your final value of y doesn't change. So don't be confused if you see it written in a different font or format in another book, but you can see that overall, it still remains the same. All right. A couple of things that we will talk about when we solve a question, I'll be able to explain to you a couple of things. One key thing is, if you remember, rho or R was used as our correlation coefficient, right? And it was able to give us this, help us to tell the strength and the direction of a correlation. Well, our R square, right, is also known as the coefficient of determination. And this is very important because what it does is that it actually shows you, it measures the proportion of variations or how a change in Y is affected by a change in X. So think of it as the percentage change in Y based by change in X. And a better way to explain it is think of it as by how much or what percent, right? Your X variable affects your Y variable. And this is very important because it's a key difference between a regression and a correlation. Let's look at a simple example that we have here, and we'll be able to explain to you some cool factors once we start solving here. So look at this question, right? It says use the data of houses in Lancaster. So these are the houses in Lancaster. These are in thousands. And then we're given the square feet, right? And so we're told to find the relationship between these two, so between houses and square feet. We're also told to find the correlation coefficient. You can see that these two are the same, right? In theory, they're the same, right? Let me make this bigger so it allows me to show you this in better detail. All right, so these two are the same. You can see that if I know the correlation coefficient, I can show there's a relationship between two of them, right? Then we're told to find the correlation of determination. We should find the standard deviation. We should find the linear regression model. And we're told to predict the price of a house with 2,000 square feet, 3,000 square feet. And then the last question, which is very important, is at a given level of percent significance of 5%, can we predict that there is a significant relationship between house prices and square feet? All right, let's begin. So the first step is to find that correlation coefficient, which we did, right? We've done it before, but let's do it again. So you have a scenario where we're told that this is our X variable, this is our Y variable. Now, this should not be a problem, right? Because we know that X affects Y, and that makes sense. Square feet affects house prices. We know that. But for this area, we need to know by how much it does. So the first part is to find out if there's a relationship between the house prices in this city and square feet. And to find that correlation, remember, we just go to our data. So at the very top here, go to your data. You select the data analysis, and you select your correlation. See how I did that? Select the correlation. Press OK. It says input range. You select all the values here. And since it's column, you leave it this way. If it was in rows, you would have changed it. Then you click on labels here. You click on labels because you want the system to know, Excel to know that the first row here, this first row here, is basically or should not be included in the calculation. And so you select output range, telling Excel where you want it to be. So this way right here. You press OK. So you can see, based on what we've learned, right? Your square feet here is 0.76. This is, so to answer question 2, so question 1, we can say yes, right? Because of question 2, right? So we know that here there is what? There's a strong and positive relationship between house prices and the square. All right, so we know that, right, by doing a simple correlation. So we kind of answered question 1 and 2. But question 3 says we should find the coefficient of determination. and interpret their results. This is very important, right? This is going to tell us by how much or by what percent square feet affects house prices. To do that, we're going to go ahead and click on data. We're going to do data analysis. We're going to go and find regression. It's right here. We do OK. It says, where does Y range go? It's okay. So Y goes here. It's asking us where X range, because we know X is square feet, right? So we'll select X. And then do that again. We do our Y. And then we'll click here. And then we'll select our X. And since we selected the top, right, we want to make sure that Excel does not calculate that. And so we're going to click on labels. And then we'll click on output. We'll click on the white space here, and we'll select anywhere here we want the output to be. All right, it's up to you. You can select anywhere you want. I'm just going to go here and just select right here. I'll press OK. And you get this beautiful output. I'm going to explain to you what this output is, because it's very important to understand why this output is very, very helpful. Right? So we're going to see the importance of this output in a big way. So the first thing we're going to do is to look at how this output is effective. So how is it effective? Well, this multiple R you see here is your correlation. You can see is the same as the number we got here. But I advise you not to use this one here, because this one tends to be positive. So if you're asked to do a correlation, you should always do it the way we did it first, because at least you're able to get a result that is, the direction is correct. What I mean is here will almost always be positive, even when the correlation is negative. The numbers will be the same, right? But it will show you positive even when it's negative. That's one. Two. The correlation of determination, which is what you're looking for, is this one, R squared. This is very important, because what it means here is that 58.1%, right, of change in house prices is affected by change in what? Square feet. So in theory, this house prices in this area is the choice people, the decision to make to buy a house, or the price of a house is affected by square feet by about 58%. So let me rephrase that. By what percent does square feet affect house prices in Lancaster? Well, 58.1%. That's huge, because that's important for buyers and also sellers of homes in that area. This is what makes regression a better tool than all the other tools we've had in the past. All right. Now, adjusted R squared usually is not used all the time. We tend not to use it, but we use standard error constantly. Standard error is the same thing as standard deviation. So if you're asked to find a standard deviation, this is what it is. So think of it as a standard deviation based on the houses that you have here, right? So if it's 41.330, then since the house prices are in thousands, this would be 41,330, right? So let's go ahead and answer some questions. So for this one, question 4 here is asking us to find the standard deviation. We can come here and say that's equal to standard error times what? 1,000, since the houses are in thousands, right? That's 41,000, right? Let's see if we can fix that. All right. The third one is asking us for the coefficient of determination, and we can answer that. That is also known as your R squared, right? And so it's going to be this. So now if they ask you to interpret your results, so you can say that 58.08% changes, right, in variations or change in house price is explained or can be explained by changes in square feet, right? So, because remember, coefficient of determination is measuring the proportion of variation in y that is explained by the variations in x, right? So that means that when it comes to house prices in this area, right, the prices is affected by square feet, but by how much? By 58.08%. A better way to write it is going ahead and saying, by saying 58.08%, right, change in house prices can be explained by changes in square feet, right? So by what percent does square feet affect house prices? Well, 58.08%. All right. The next one we're asked to do is, what is the linear regression model? Now remember, right, one thing I wanted to add is that not only does regression go ahead and show you the relationship between two variables, it also goes ahead to help you predict. With linear regression, you can actually predict based on your given values. So I can predict what y would be as long as I know what x is. So that's the scenario here. If I'm able to create a model, I can use the model to do what? Make predictions of house prices. So someone can say, okay, if this house has this many square feet, based on the model created from all the houses in Lancaster, the price should be about this amount or this number, give and take this standard error, right? All right. So that helps a business person to make predictions about tomorrow based on the information they have today. And that is what makes regression a very cool tool for business, for individuals, and for society as a whole. So here we can create a model here. And remember, right, we said that to create a model, if you remember our formula, right, then that's going to come into play here. Remember, we said our y is equal to our intercept, beta naught, or sub O, plus, right, our regression slope, x, right? This is a regression model, right? So we can be able to create one here. And the beauty of this is that it makes our life so much easier because it's right here. See, we have it all here. The intercept is here and the slope is already here. So all we have to do is now say, okay, so our linear regression model will be y is equal to, right? If you see the first one, it says our intercept, right? So that's 98.2483, right? And what is our slope? 0.10977 x. For the purist, I'm just going to add 3 here so that you feel more comfortable with 5 and 5, right? So what you've created here is what we call our regression model. Why is this important? This is important because you can use this to make prediction of Y based on this. So if I want to make a prediction of Y, I can do that as long as I have X, which is my square feet. And that's what brings us to the next two. We are asked to predict the price of a house that has 2,000 square feet and 3,000 square feet. You see, we can do that, right? If the house is given as 2,000 or as 3,000, we don't have a problem with that, right? We can make predictions because we know what the model is. So let's do that for the first one. So we can create this to look really nice so that we don't have to struggle about it. So we can come here and say, all right, for this first one, this is the slope intercept here, right? And then for the second one, this is our slope, right? So that's what we have. We have our intercept here, we have our slope. But we're asked to find our house price for square feet if it's 2,000, right? We can do that, right? That's equal to, remember, this is 98.24, right? You can click on this number, plus, right, plus, and this is our slope, right? And then we multiply it by what our X is, right? Put them in parentheses. What do we get? 317. But remember, right, these are in thousands. These houses are in thousands. So to get the real price, I just have to multiply it by 1,000. Right? So that tells me that a house that has 2,000 square feet will be about $317,783.81. And I can do that for 3,000 too, right? I'm using the same formula, right? I'm using the same formula. And that'll be equal to, right, 98.2483, right, plus my slope, right, times what my X is. And we're trying to obey to make sure we follow the laws for your basic algebra, right? And so we're able to get that. Same thing. We can multiply this by 1,000, and it tells us how much that house is worth for 3,000. See that? So we've solved these two questions. We're able to forecast now and predict that houses are 2,000 or 3,000 square feet. That's the price that the house will go for. Now, if you wanted, or if you are asked to provide a linear graph, you could have. So there's something that I didn't show, but if you were asked to provide a linear graph, you could have. So under your data analysis, when you did your regression, you see here, line fit plots. If you clicked on line fit plots here, what it would have done is it would have created a plot for you. So let's see. Let me show you that. And that's just depending on what kind of question you ask. So you can see it has created that for you. Right? So you can see this is your line plot here, right? Line of best fit right here. So the orange one is your line of best fit. The blue ones are the real values. And you can see they are very close to the line. And that's why you have a strong relationship between them. Right? So that's if you are asked to do that. Now let's do the last part. The last part now says, at 5% level of significance, can we predict that there's a significant relationship between house prices and square feet? Now, this is very important. How can you tell if the relationship between house prices and square feet is significant? Well, the way you can tell if it's significant is if you remember, right, in basic algebra, right, one of the things you learned is that if you have a scenario with straight line, right? If it's in this form, that means that your slope is positive. If it's in this form, then your slope is negative, right? But when you have a scenario where it's a straight line, right? Then what it tells you is that the slope is going to be 0, right? And what it means is that there is basically no relationship between your y-axis and your x-axis. That theory is applied here, right? So for us to test if there's a relationship between house prices and if there's a relationship between house prices and square feet, well, we can do that using our hypothesis testing, right? Remember, in our formula, right, remember in hypothesis testing, we tend to use population mean, we tend to use population. If you remember when we're doing our regression model, we said your y was equal to, this was your intercept plus your slope, right? We can see your beta here had a small b, which stands for your sample slope. But for this, it will be a population slope. And so it would be in the form of, right? And this will be equal to 0. So if your population slope is equal to 0, that tells you clearly that there's no relationship. But if your population slope is not equal to 0, that means there's what? Relationship. Remember we said slope, right? If it's equal to 0, that means there's no relationship between these two. But if it's not equal to 0, then that means there is a relationship. Now, if you can write this in this format, all good. If you cannot, let's say population slope is equal to 0. And for h sub a, population slope is not equal to. And you can write it's not equal to, or it's really up to you, or you can come here and you can select the symbol here, which says it's not equal to. Right? So we have a scenario here. We know that if we're able to reject a sub o, then that means there's a relationship between these two variables. If we are not able to reject it, that means there's not a significant relationship between those two variables, right? So let's solve this. And this actually is very easy, because now you don't have to stress yourself to do any of this because the system provides everything for us. So remember, we're told from the question, let's go up and you take a look. We're told that the level of significance is 5%. So we're already given the level of significance here. So our level of significance is given as 0.05. We just need to find our p-value, and then we have to compare. But the p-value is actually provided. See p-value here? We don't have to stress about this provided for here. And this is the intercept, so we don't look at this. We look at the p-value for x, which is this one. And so you can see that p-value is this number. That is our p-value. And you can see our p-value here is what? Less. Remember that when your p-value is less than your alpha, you do what? You reject. A sub o, the p-value is greater than alpha, you fail to reject. Right? So in this case, we can see that our p-value is less than level of significance. So we reject a sub o. We reject this. And what does that mean? If we reject this, that means we're accepting this, right? Which means there's what? That population slope is not equal to 0. And if it's not equal to 0, that means it's a relationship between the two of them, right? So at 5% level of significance, we can conclude that there is a significant relationship between house prices and square feet. Right? I hope this video was helpful and you're able to understand how to solve questions involving regression. And it was able to help you get a grasp of the concept that we learned today. All right. I hope you have a great day. Thank you. But before I forget, you also have a chance to get some extra credit, right? And to get the extra credit, you want to try question 4 and also question 5. Thank you.